Recording in progress.
Good evening, everybody. Can you hear me?
Yes, hi.
Hi, Shreya. Thank you. Thank you, Palami. How are you doing? And did you try a bit about Grasshopper, Suniti, Aishwarya?
Yeah, I did something little bit about it. So we looked at some sites.
Mm-hmm. That's good to know. And Aishwarya, how are you doing? Everything good at your end?
I'm struggling to install the software actually.
Install the software. Oh, okay.
Like
Right.
it's not happening. I don't know.
The Rhino, right?
Yeah,
Okay. Like another ID is also not working. Email ID.
no. Like I used it in this PC, so I can't reinstall it in this PC.
Ah, okay. So it is like connected with the device.
Yeah,
Mm, it's okay. We'll just follow through the session, and maybe later on you'll be. Anyways, the recordings will always be with you. So definitely, if you have any queries during the session, also don't forget to ask.
yeah. I'm following the things, but I am just not able to practice it.
Yeah.
But I'm understanding the things.
Thank you. No worries. Perfect. Hi, Pratiksha. How are you doing? I can see your audio is connecting. Okay, so today we'll be looking at a bit about sustainability concepts and the simulation plugins. And many of you are familiar with sustainable um, sustainability related concepts, right? Like daylight factor and um, solar radiation analysis. Sharvari is not here. Shreya and Ashwarya, you both um, are moving towards sustainable design. Shreya, you have done MSc in sustainable design, and Ashwarya, you are going to do masters in sustainability. So this would be pretty interesting. Follow me also. You have done sustainability in NIT. And who else is there? Shraddha. Shraddha, I'm not. Shraddha, sorry, I think I missed your introduction. Hi, Shraddha, how are
Yeah,
you?
Yeah, hello, I'm all right, sir.
Yeah,
I'm here from Mumbai and
yeah,
I'm a professional architect.
yeah, yeah.
And yeah.
And so, what about Grasshopper? Have you ever used it or? Uh,
So what happened actually previously, I wasn't unable to access the recordings. I talked with Kuldeep today,
oh, okay,
and
okay, okay,
he
okay.
told me in detail how to access those because of some electricity and internet issues
Ah,
and
okay, okay,
the
okay.
thunderstorms in Mumbai. So
Oh,
at
yeah.
that time, I was unable to access the meetings.
No worries,
That's
no
why I
worries, no
missed
worries.
some sessions. But I will go through it and then
Definitely,
I can match up with all of you.
definitely, definitely. No, I was just asking, like, before these sessions, have you
Mhm.
heard about Grasshopper or used a bit, or this is the first time?
Yes, sir. I have heard about it, but I haven't used it yet.
Understood, understood. Perfect.
Yeah.
Pratik, I just got your message. Thank you for your message. It's okay. No worries. You've got a mic issue, and all right. So yeah, we'll quickly go through a bit about sustainability concepts, and then we will move on towards simulations because we should know why we are doing what we are doing. Okay, let me share my screen. Oh, before I start, is there any question for the previous session? Like maybe you opened up the Grasshopper file and played with the twisting tower or something, and you have any query? I would love to resolve it. Yeah, also, if there is any query, you can just put it on the chat, uh, and we will take that up whenever we get a break or gap. Yeah, sure. You want to say something?
Yeah, the last script I wanted to try, but
Okay.
we started it with a rectangle grid,
Right.
and I cannot find that command in my Grasshopper.
Ah, the rectangle grid. Oh,
And the alternative one also, like you showed grid structure, that also I tried to find it's not there in my Grasshopper.
okay, okay, okay. So I think maybe it was from a plugin that even I missed out. So thank you
So
for that.
when I pulled your file into mine, I
Yeah.
see a white box. So
Huh.
I don't see anything in the perspective.
Right, right, right. So I'll replace it with
Usually
some.
what is, yeah.
Yeah, so I'm very sorry. I thought it was a native grid command, but it is actually a plugin grid command. I mean, so whenever you don't have a plugin installed, um, this would happen. It would show a white box. I'm really glad you tried it and this happened. I'll resend the script with replacing it with some normal command.
Okay,
Yeah, yeah, yeah.
sure. Thank you.
Thank you for the doubt. Okay, I'll just note it down. All right, let's um, share my screen. I'm opening my presentation and we'll begin. Mm, okay, so I'll just so we have a total of 4 sessions. 2 sessions are done. First one was introduction to Grasshopper. Second was uh, how to um, apply logic. What is a logic? Like we tried that attractor curve logic, and we get more familiar with Grasshopper scripting. Today is the third session, and then there will be one more session. Sorry. Today's session will be about Ladybug and Honeybee, about environmental analysis, about sustainable concepts of um, solar radiation analysis, sunlight, sun hour analysis, daylight factor. And then finally, the last session will be combining all of these together and showing you the like if you move on with Grasshopper, if you learn more and more, to what end or towards what direction you will move towards. So the last session will be an exploratory um, session, which will have the combination of what we have learned, how it is applied, and what more things are there. So I'll just give you a glimpse because going into depth would not be feasible in terms of time. Okay, so today's session is about environmental analysis. Mm, okay, so first we'll look at these concepts. What is illuminance, luminance, daylight factor, daylight autonomy, useful daylight illuminance. So Honeybee is the plugin that deals with all of this. Um, After we go through all of this, then we'll look at how to install that very quickly, and then we'll make some block models, and I'll show you the power of simulation in Grasshopper. What are the possibilities that is in Grasshopper? So let's not go into detail of all of this because I think other sessions will cover these things as well. And of course, you already know most of these things. What is illuminance? It's just a measure of light received on a surface. So this is useful as a quantification of how much light is entering a room naturally, right? If you turn off all the lights and then measure in lux. So even your mobile can have this app for free where you can measure the lux, what's the light inside the room, and you can. So this is an exercise we did in even in bachelor's, I think. We make a grid, have several points, and then place our mobile at all of these points, and then mark what's the amount that is coming in, right? Is it 200? Near the windows it will be more 500, 800, and towards the corners of the room it is very less. So what I'm getting towards is instead of saying, oh, this room has too much light or room has too little light, this is very subjective terms. For you it might be too little, for me it might be too much. And computer does not like subjective things. Computer wants things to be very quantified in numbers. And so we quantify this light in terms of lux and then discuss it with computer. So yeah, for example, this one. Okay, so I forgot the name of the device. Do I have it here? Okay, so this is a device which measures what portion of room has how much. Here it is candela per meter square, another term, another unit. And if I can zoom in, here it is showing the dark places has only 16.2 candelas per meter square, the bright areas with 40, 44. So I told you the first method of measuring, we take the mobile or whatever that sensor is and place it at different corners, different points of the room, make that sheet, and um, average it out. And if we get the average as between 200 to 500 and it is a residential room, it's fine. If it's a classroom and it is 200, it's not that good. Okay, so that's like one way of measuring. But the problem is, we have a window and then I measure it and then I change the window or like open or close some windows. Then I have to do the entire process again. So it's very time consuming. This would allow it to be quicker, right? I've got that device. I measure everything. It gives me the grid, and then I tell people to open the door and light windows and other like ventilators and stuff, and instantly I get another set of values in my device, right? But this is good for things that have been built. We are going to build something. how to predict how much light is going to be in there, that is where simulations come into place. That is where Grasshopper will be used, Honeybee. Daylight factor is a thing. So we place a light sensor outside, in direct sunlight, um, and then we place the device inside, and then we take the ratio. So how much percentage of sunlight am I getting in indirectly? So that's the daylight factor. So it is always in percentage. 100% means there is no roof. 50% means whatever brightness is outside, 50% of it is inside, through the windows or anything. And it is usually measured 0.8 meters above the floor. That's the working plane, table height. So I'm pretty sure you know all of this. We are just revising because um, we are going to use this in the simulations. Um, then these are the factors that govern the daylight. Um, the size distribution of windows, the size and configuration of spaces, of course, the reflective properties, if it is being reflected from roof and then getting in, then the percentage will be higher. The degree to which external structures obscure the view of sky, so this is important. So if there are trees and buildings, that's gonna obstruct the sunlight and will give you a different daylight factor than if they all were absent, like just my building and sunlight, and I calculate, I'll get something else. But if there are, I mean, that's common sense, but I'm reinforcing this fact because I'm going to create such an environment in Grasshopper. We are going to create these objects and buildings and then see what happens. So this is an example of how that heat map would look. Um, Usually daylight factor is very less, it's 0 to 10%. It's not much. So yeah, in this case, the blue part is 0, so there is like complete darkness. And actually, if I can zoom in, there are skylights, dotted rectangle skylights. I hope you can see that here. Is it visible? Are these like rectangles visible?
Yes.
Perfect, perfect.
Yes.
So here there are these windows. I think these are full length windows, and that's why so much light is here. The daylight factor is going beyond 5%. And here there are skylights. Probably they are translucent, or maybe they are obstructed. That's why it's 4 to 5%. And on the right side, there are skylights that are placed in a grid fashion. 6 skylights, equally spaced, and that's why the entire room is lit, um, like naturally lit uniformly. Okay, and this is then daylight autonomy. Um, Daylight autonomy is a daylight availability metric that corresponds to the percentage of the occupied time. So we do not only want to know how the room is performing as an object, but the room will be inhabited by people during certain parts of the day, right? So daylight autonomy is more towards user centric measurement. And so this is like useful daylight that is done. So I mean, we are getting daylight from 6 to 8 a.m. through east, and that will come under my daylight factor calculation. But there is nobody from 6 to 8. And what if like through the next of the day it is shaded a bit, and the daylight factor is reducing? So to be more realistic and more accurate, we use daylight autonomy, where the time is also specified. Um, yeah, and then that gives me useful daylight illuminance, UDI, where the time is defined and the daylight factor is also considered. Okay, that's daylight factor. So let's move on to the um, grasshopper part. Now, I've put in daylight factor and talked about it, but the solar radiation analysis, sun hour analysis also run on the same concepts, and they are much easier to understand. It's pretty obvious, and it is not complicated like this one. Solar radiation is basically just the building. What amount of solar energy is falling on per square meter of that building surface? That's it. There is no complicated how much, like there is no relative solar radiation or anything else uh, like that. Similarly, sun hour analysis is exactly the same. How many hours of sunlight is directly falling on a surface, considering there are other buildings nearby. Um, so in my uh, thesis, there was this. I was basically talking about how the construction is currently in Mumbai because of high-rise buildings, especially in the places where they are creating rehab buildings and then creating tall buildings for sale, not considering the shadow that would fall onto them, because we need sunlight. Sunlight prevents algae. Sunlight reduces moisture. Sunlight is required for vitamin D and all of that. There are research papers that connect sunlight to tuberculosis, which is pretty crazy. Um, so we need sunlight. In Africa, it was defined as 2 hours of minimum sunlight should fall. In some place, it was 4 hours. Some northern hemisphere countries, I think Scandinavian countries. But in India, there is no such bylaws that states that at least 2 hours average per day sunlight should directly fall on the surface of the building. Uh, so yeah, there's a long story behind why this is important to have this as a bylaw or as a guideline, um, which we'll talk about in the next session definitely, and everything will piece together. So yeah, any questions so far? Okay, so we've got Rhino and Grasshopper turned on. I'll be talking about how to install plugins. Normally, plugins are very easy to install. Not very easy, but more simpler than Ladybug and Grasshopper, Ladybug and stuff. Where you go to Food for Rhino. Just a second. Food for Rhino, and then you can have any plugin you like. Let's say Elk is a plugin that I want. Elk is a urban designing um, tool that uses OSM data, OpenStreetMap data. So we simply download it. Of course, we have to log in, create a account and log in. And mostly things are free here. As soon as you click download, you get that download. We get a .gha file. Sometimes you get a folder, sometimes you get a .gha file. Okay, so let me show you what you have to do with the GHA file. I just put it in my desktop for now. When you have your Grasshopper open, you go to file, then file, then special folders, then components folder. Okay, file, special folders, components folder. As soon as you click that, this thing opens up automatically. it opened up at my different window, but and you can see like normally it is empty, but I have all of these plugins installed, and then you simply drag and drop it here. Okay, so elk gh, I already have elk, that's why it is showing that one thing. And one important check that you have to do is right click, properties, and in security you have to do unblock and apply. So this is the easy way to install all these plugins. um, I'll just quickly go through it again. As soon as you download a file from Food for Rhino, you put it anywhere you like. Open your Grasshopper, file, special folders, components folder, drag and drop, right click, set properties, settings, and now I don't have this, but in security check if you have to unblock it. Sometimes you don't have to unblock it, they are already unblocked. But sometimes you have to do that, otherwise it won't work. Okay, so that's the process. So now you know, like whenever you want to download any of the what do you say, plugins, you can do that. But there are several plugins that are not that simple to download, like Butterfly and many more. There you have to research a bit, even in their forums, like how to download it. Sometimes they tell us to put some files in user objects folder. Like even here you can see these honeybee, dragonfly, Wolsey, ladybug. So it's a bit complicated. But for the basic plugins, 90% of the plugins, it's just what I just told you. In the case of ladybug, I have a sad news, because in my last class I was very happy for my students, because um, when I searched for ladybug, it had so like here you can see download, it had install written here. So like right now all of them are download, right? So when you click on download you get a file, but there was a time where there was something called some version with install written on it, and as soon as you click that, it automatically opens up your Rhino and gets everything done. So that was a very easy process, but for now we'll have to do the long way. So click on download. I had shared this link on the WhatsApp, so you can do that right now. It's just 23 MB, so it won't take much time. Okay, so it is downloaded now. I am putting it on desktop. It's in a zip file, so I'm gonna extract it out. Okay, so here we have the file. Let's delete the zip file. Now when you open it, you'll see installer.gh, uninstaller.gh. Now if you already, like you can already see the difference. When we were doing this, the original way of installing a plugin, we had gha file, .gha. Let me show you. And they're green in color. Can I zoom in? Yeah, they're green in color, they're .gha file. But here we've got a normal .gh file. So that's where it begins to bifurcate. If you look at installation instruction, they say that a free single click installer is available for Windows only. I just checked, it's not, it is paid now. This Pollination Grasshopper installer, I just checked yesterday night, it's paid, so we can't use that. Full list of installation instruction can be found at github.com. Now GitHub is a place, it's like a blog kind of thing where all the coding guys put stuff in it, scripts and everything. But yeah, just let's just forget it. And double click on installer or drag and drop to your opened up Grasshopper, and you will find this. Okay, so in my time, there were like 4 steps, and it was a bit complicated. But here it's, I think, very simple. All right, so it is saying make sure you're connected to the internet, which we are, of course, and set setup Python to true. This is setup Python. So this is toggle. You double click on this false icon, okay? And then don't do anything. Don't like triple click or single click or do anything. Double click and wait. Oh, it happened. Next, you should run the install component below. Okay, let's do the same thing. Double click and wait. So it is not showing any loading screen or anything, but it is happening. Okay, don't disturb it. Oh, I already have Ladybug, so probably there will be some clashes. But um, but yeah, right now I can't even zoom out or zoom in. It's gonna take its time, and in the background it is running all that installation stuff. Even the Rhino is not opening. Is anybody installing it right now with me? Okay, sure. Let me know if yours uh, get installed before me. That would be nice. Okay, Pratiksha. I think they have combined like 3-4 steps into one, and that is why it is taking so much time. Because I remember it takes like a few seconds to a minute for each of these steps. Um, mm, can you please tell me what is to be done after dragging the file in the Grasshopper? So after you drag it to the Grasshopper, uh, you will see this. What you can see on my screen, there are like two this toggle switches. So first, double click on the false box, like here. Double click on it, and um, I can't show you because my thing isn't working. Okay, so once you double it and it becomes true, then double click on this second toggle. Okay, Pratiksha? Oh, finally. Um, Let me see. Is there an error? Ah, okay. Ladybug Tools 1.8 has been successfully installed. Restart Rhino to load the new components plus library. So whenever you install a plugin, sometimes you have to restart your Rhino. Not always. Oh, right. There is also another way to put in a plugin. You can simply drag and drop, but that does not work all the time. Sometimes it works, so you can just drag and drop your GHA file and it works. But of course, for let me not confuse you. For Ladybug, it is this process, and it has worked. I'm really surprised. And as you can see, this is showing me different things that it has installed on its own. Um, Okay, so that's Ladybug is installed, and Honeybee, you can see Honeybee Open Studio is installed. Honeybee Energy Standard, Ladybug. Okay, so let me switch this off. I'm really happy this worked instantly, but I hope this continues to work. Okay, let me turn that off. Let me turn this off. and uh, usually don't do this. I mean, unless you have completely forgotten to save your Grasshopper file, only then click on this because it is very glitchy. So I never do this. I have lost a lot of my work because of that. Pratiksha, did your installation get completed? It takes around like three. It took around 3 minutes in my system. Okay, okay. It will work. I hope. Some error. Um, can you share your screen or like just copy paste the error what it's saying? I'll send SSO on WhatsApp. Cool, no worries. Um, is your Rhino 7 or is it like older version? I think even if it is older version, it should work. Yeah, it should work for Rhinos. Oh, okay. So Rhino 6 to 8, it will work. Is your Rhino? Oh, it is 6. No, no, that should work then. Yeah, send me the screenshot. I'll check. Um, wait a second. Okay, I'll just share here because there is no information, sensitive information. Okay, so the thing is, runtime error, download failed with error, remote name could not be resolved, storage dot Google APIs. No idea. No, since the first installation did not work, of course the second one wouldn't work. Um, so whenever such errors happen, like such errors happen a lot. So what I usually do and try to get solution is type in the same error on Google. The remote name could not be resolved. Storage.googleapis.com. And then I'll just write in some keywords like grasshopper, ladybug. So people have gone through the same errors, and I go through their forum, like see exactly the same problem. I think. Oh no, it's different. Line 67. Where is my? Okay, so yours is line 81 and 160. Okay. So people are saying like normally the errors occur because of lack of um, internet connection or firewall blocking your plugin. Um, so it looks like something is blocking your internet connection. Of course, this error is not the same, but that could resolve it. So in your firewall, you have to turn off some stuff. So the issue has resolved by turning off firewalls when installing the tools. So yeah, turn off the firewall and then that should hopefully work. I remember it has something related to firewall stuff has worked with me, but I don't remember which plugin. But sometimes these things happen. Okay, we'll move on. And so yeah, Pratiksha, oh yes, that PC isn't connected to the internet. Cool, cool, cool. Perfect, perfect. So yeah, I mean that's how you resolve almost anything in Grasshopper. Because it's something like YouTube does not give many sources and solutions. we have to go into these forums and like text-based sources. Okay, thank you for asking, Pratiksha. That's really nice of you. Let's go back to our Grasshopper thing. Now we have this file where we took the installer.gh from, right? Many of these plugins, especially the plugins which are huge, which are complicated, they have got these samples, and um, these samples allow us to. So the samples are basically a sample of Grasshopper script that is already made for you, and you can plug in your geometries, tweak those parameters according to your context. But at least the script is made for you, so you don't have to build it from scratch. So let's try Ladybug, the basic. And then in Ladybug there are so many things. You can do visibility study, which actually gives you it does like ray tracing, and then detects how much is the visibility at different points of the building. There is solar envelope, radiation study, psychrometric chart. Oh yeah, and even the windrows diagram, psychrometric charts, all that can be plotted on Grasshopper itself. Um, for just like a quick revision of what that is, a psychrometric chart is basically a graph for a city, which it is basically a conglomeration of data that you can get um, if the city is too hot, too cold, too moist, sorry, too humid, or too dry, by looking at where the majority number of days is plotted on this graph. It's very difficult to explain in words, but yeah, it's you can look that up. Then there is comfort, shade benefits, direct sun study that you can do. So let's do radiation study. Double click it, and it will open up. Now keep in mind that simulations are heavy, computationally heavy. So they take a lot of time. So make sure to take it slow. Like, don't just do random stuff and see what happens. That we can do in that twisting tower thing. You can put like 100,000, and the tower will have 100,000 flows. It will take like half a minute and it will do. But here, if you make even just one mistake from 3 to 2, and just like the slider, the computer is gonna freeze, or that Grasshopper is gonna freeze, and your file will not be able to even save. So be careful for what you do. For example, the biggest error that happens is, you saw that heat map, right? In this, and you can see that there are these small squares. So here we are telling it to analyze for that square. So probably that square is 0.5 meters by 0.5 meters. And accidentally, if I say it is 0.5 millimeters, then imagine the amount of computation it will start to do for this small room, and it will get stuck forever. Okay, so my Grasshopper is opening. It is saying Rhino 7 is not responding. So I'll do wait for the program to respond. I cannot drag it in because it is stuck in on my other screen. So just wait for it to, yeah, it's worked. My thesis file, if I keep it on run and then close it, and then when I have to open it, it takes like 10-15 minutes to open up, and it just shows not responding. So you just have to like have faith that after some time it will start. So that's a bit of a bad thing about Grasshopper, that it does not give me a loading screen or anything. It just shows not responding, and then we have to assume whether it has stuck or it is processing because it's the same for both. Okay, so it is a running script. I'm really happy that it is working. This is orange because here it is false. Like, and it is telling it is like giving me the command run me. So if you run that, then that will work, but I'll not do that right now because let me show you what's happening. Okay, so there is some native um, box they have, a building, you can say. On the left hand side, we've got import weather data. Of course, we need the weather data. If you remember, I was talking about energy plus weather file, EPW file. It has the information of how the sun is moving, the DL, dry bulb temperature, the wet bulb temperature, humidity, relative humidity, everything. And that we have to put it here. It extracts the data from it, and then it takes what we want it to take. We want to take the direct solar radiation. So it will take that. We can tell it from what month to what month do you need to simulate it, like consider. I just want to check the solar radiation during summers, and that I want to minimize. Okay, so I'm just gonna simulate that much. So that's all what we can control from here. We need the city's EPW file. I'll just show you how to get that. And secondly, we can tweak what days we want to simulate, what days and what time we want the simulation of. Then we come to the geometry. Okay, so when I click it, this should get, oh, so okay, so interesting. It is looking at the solar radiation falling on the ground, and then this geometry is the context. Oh, so interesting. So it is probably it just wants to see whether the ground, what part of the ground should be allocated for parking lot and what part of the ground should be allocated for playground or human use. So the context is the building, and then what we are testing is the ground. Okay, and this is the grid size. So that is 1. I hope that's meter. We'll just check once. So the grid size is the heat map grid size. Offset distance is oh yeah, right. Offset is just like slightly up above the surface. Sometimes it is like merged, then it does not look good. Sometimes you have to do negative 0.1, so if you want to see it from that side. So that is why we need offset distance. Okay, let's run it. I've double clicked it. Now I'm not going to do anything. It'll work. Yeah, it's working. Perfect. Okay. Let me hide the plane because it's merging with that. It's so smooth. Interesting. So the solar radiation is coming from the southern side, if this is south. Sorry, the sun path is like going from the south, so we are in the northern hemisphere. And this portion is very cool, and then it slowly goes on increasing. And we can see the values also. Let me see. Total value is this much. That's 3.6 into 10 raised to the power 6. That's the total value. I think it's just adding everything up. What we can do is we can divide the entire thing by the area of what we are checking about, and then we will get the kilowatt hour per meter square that we want. I think I'll do it right now. Sorry. So the total value is divided by the area of my context, oh sorry, my geometry, the base. And then hopefully we are gonna get some nice value. 724, around here. So it is now averaging out the entire area. Okay. So, first thoughts, like, what are your first thoughts? What's going in your mind? I would like to know where you're at. Sunidhi, Shreya. Mm, okay, then we will move on to how to get the EPW file, energy plus weather file. Um, because this building and this plane can be anywhere in the world. So let's say we have got the exact building and exact plane in our city, then what we're gonna do. So Shraddha, you're from Mumbai, right? So let's take um, a Mumbai EPW file. So just type in Mumbai EPW file. Okay, Sunidhi, no problem. And then there is this website called onebuilding.org. Let me send that on WhatsApp as well. Oh, Pratiksha, I just saw your message. Wait a second. Oh, no, 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 no. Okay. You clicked on LB setup, right? Um, so wait a second. What did you click on? Um, the Python script should not open up on its own. It opens up when you double click on that component. Yeah, how do I explain? Yeah, so you have to click here. Pratiksha, you here? Yeah, so you have to double click here on this black word. Oh yeah, you clicked on this one. That's why the Python opened up. Just close that Python down. It's just showing what's the background script of it is. You have to click on this thing. So here it must be written false. So double click on that and then it will turn on to true. Perfect. I'll just write like answer on the WhatsApp as well so that for others it is helpful. Uh, just a second. Okay, I'll do that after the class. I'll just write it down. Please try turning on internet or a firewall off. Okay, and for the third one, we set up a double click on the false button. Okay. And then I was gonna write about the Climate One buildings. So this is the website. Quick recap, I typed in Mumbai EPW file, I get this website, Climate One buildings, building.org, because I always forget the website's name, but whenever you type in EPW, you find that at the top. Okay, now you have to search. We are in Asia. Then we are in India. Where is India? Southern Asia, India. Here it is divided state-wise. Andaman Nicobar, Andhra Pradesh, Arunachal Pradesh, Assam. And so yeah, we look into Maharashtra. And everything is in, what do you say, alphabetical order, so it's easy to find. Here is Maharashtra, and then we are looking at Mumbai, Mumbai. Mumbai, we've got several files. As you can see, these files these files are from different weather stations. So there's a weather station in Andheri, which has got some data, and it is taken 2014, the accumulation till 2014, I think. This one is Shivaji International Airport weather station, which has data from 2004 to 2018. We would like 2007 to 2021. That is more closer to today. So yeah, I'm gonna take in this one. Mumbai Shivaji International Airport, 2007 to 2021. You just single click it, and it's a very small file, as you can see, 421 KB. I also have this file with me. That's why it is like showing two, because I used it for my thesis and research. Okay, so let's drag and drop it here. Oops, drag and drop it here. What's happening? Um, where is the file? Oh, okay, okay, okay. Here it is. Oh, what? So it's a zip file. Then I extract it. Extract. Um, it's on my other desktop. I delete the zip file. Oops, sorry. Yeah, I delete the zip file. I've got the original file intact. I double click it. I get these files. Expand the name and look at these extension. Let me zoom in. Okay, so extensions are .clm, .ddy, .ebw, .pvsyst, something else on it, .stat, .wea. So I have used epw, stat, and wea. In this case, we need epw file. And just for fun, let's open it up and see what's there. It looks like gibberish, but actually it is really nice information which they have somehow managed to encode into it. So on the left, you can see there is 2007 111 330. So I think it's 1 a.m. of 1st of January, but there is no data in it, I think. And then there would be some coordinates, latitude, longitude as well, somewhere here. We go down, down, down. So this is what I meant when I was saying that they have a lot of data inside. You can see now it is at 2015. Oh, now it's 2007. I want to come to the part where there are tables. Okay, so there are no tables here. Okay, so all of the information is somehow just like into it, which we cannot read. Like, for example, this 342 could be the solar radiation, average solar radiation um, in kilowatt per meter square. Probably, I don't know. But that could be one thing that it denotes. Some of them could be temperatures. I think this is a dry bulb temperature. No, but then here it is 74, so it couldn't be. Probably it is relative humidity. So at an hourly basis, it has data from 2007 to 2000 now. So EPW file. Let's take that, put it on the desktop. Close it. Close. We don't want this. We don't want this. Okay. Now, oh, it needs the stat file also. No, perfect. So I'm going to double click and type in file, file path, right click, set one existing file, desktop. Where is that? EPW file. Open. So this EPW file will go here. Okay, let's first toggle this off so that it does not crash. So I put the EPW file here, and I need the stat file also. Where is the... Oh, wait a second. So I'm gonna take the stat file, put it here for now. right click, select one existing file, desktop, stat file, open for the same city, and then connect it to here. What they did is a bit different. They uh, they took the URL and then put it here, but whenever I do that, I don't know why sometimes it does not work. I find this to be the foolproof method. I'll just type in Mumbai stat file, and here I can type in Mumbai EPW file. Now it will work for Mumbai. I've double clicked the false button and now it is working for Mumbai, and as you can see, it has spread out. I think like these yellows have spread out a bit. And if you remember, last time the yellows were around 700, 800, but this time it is higher, because earlier we were looking at some in America, some city in America, Wisconsin, which is a bit cooler than Mumbai. So here the average will come higher than that. Last time in that case it was 720 or something. This time it is 980 kilowatt hour per meter square. So yeah, even this one was 3 point something into 10 raised power 6. This time it is 4.9 into 10 raised power 6. So yeah, it works. It works very well. Per meter square, perfect. Now we see what else we can do. Let me just turn on this building. Context. Oh, what did I do? To show you that this can be used for the building facade, like what's the radiation the building is absorbing, let us build some boxes. So there is a command box in Rhino, and throw in some buildings. Like this is really cool. Throw in some buildings close to it. The sun is coming from south, right? So let me place a building like close to south to see what happens. Right click and go to shaded so that you can see these solids. Let's have geometry blocks. Oops, sorry. Copy paste. Now the geometry here, you can see this geometry. Okay, I'll just move a bit back. This is our main block, run radiation study. This block, incident radiation. Here is where the geometry is being selected. Okay, in that there are two types of geometry. One is geometry and one is context. Geometry is that are those surfaces on which this simulation will run. So in my case, I want this to be made. This is my building. So I'm going to select that, right click, set one geometry. Okay. If I click on it, I can see that this is being highlighted. And I'll do set multiple geometries for the other one. 1, 2, 3, 4. Enter. Okay. Just check. All of them are selected. All of them are turning green. Now turn this off. Then shift. Then change this. Okay. We need the area. Yeah, we need the area. Control plus shift to take all of these outputs and put it into here. I'll just write this as my geometry, and here it will be context geometry. The context geometry goes into here. Everything will happen really quickly because this is set at false. Now as soon as I double click it, we'll have to wait and see what happens. Double clicked it. and it has worked. So right now it is not looking good. We need to hide in Rhino. Like on the Rhino, you created that box, right? So click on it and then type in hide and enter. And still it is not looking good because now we have to hide the this geometry. Middle mouse button and hide. And then we get a nice smooth. Oh wow, it is even showing, I think, shadow lines. So you see all these blue part, that's like very less solar radiation coming in, and the terrace is completely exposed, so it is all red, and you can get the values from here, and this is like average. And now the best thing is you can actually see the live impact of what you do. Um, let's let's move all of this geometry. Like either we are moving the entire plate or we move this building, it's the same thing. So we can move the entire city to the left. Okay, I just moved it once and then I waited. I'm waiting for the computation to occur. And you can see it's slowly moving towards yellow. Now don't be deceived by the colors because these values are increasing and decreasing, as you can see. Somewhere it is the same yellow is 700, sometimes it is the same yellow is 980. That is because it is simply taking the least and the maximum value and then creating its uh, what do you say, legend. You can create custom legend, let's say 0 to 2000, and it will remain like that. That you have to do separately. You see this legend thing? We have to double click and then type in legend and then uh, LB legend parameters. Um, and then do like put in the values that you want. You can um, like customize it to the core. You can customize what's the accuracy, how many decimals you want, what's the minimum maximum, what's the segment count, what's the color coding that you want. Probably you want it maybe grayscale colors, so that's also what you can do. Text height, segment with everything, and then you put that into legend parameters. Oh, I think I shouldn't have done that. Okay, nothing happened. Great. So yeah, so you have to play with it a bit to understand how is it doing, but that's a possibility that I'm just sharing. I leave this legend uh, par in this um, gh grasshopper file. So yeah, that's how it is. Now also you can do show to get your original geometry and then rotate it if you want. You can just select that blue semicircle, quarter circle, and then drag it to rotate it. And it took a while to compute. Let's hide it again and see what happens. So here the shadow is coming. Here it is all exposed. But I think this is towards the north, so anyways the sun is not very harsh on the northern side. On the southern side it is pretty harsh. Okay, so that's how we do solar radiation study, and that's the thing. Like if you understand this, then all the other, most of the other analysis, the sunlight hour analysis, the same thing happens. You get a heat map, and then you can control it however you want to. I didn't tell you about the days. So let me explain what's happening here. What is HOIS? So here it is looking at, I think, a single day, 21st of 7. 7 is January, February, March, April, May, June, July. 21st of July, this is the result you are getting. So you can imagine, like if I ask it to run a simulation for a whole month, it's going to take a lot of computation and a lot of time. Let me just change the month. I think we'll have a very different outcome. Let's take December, start month, end month, and Is it? Did it change? Oh, let me do it again. So let's say it was 7.
To interrupt, how are you setting the north in this to understand?
How am I setting the?
North to understand whether the
Ah,
communication is working fine.
not okay. Okay, so there is a sky matrix, the sky dome that is actually hidden. I forgot to tell you about this also. Just a second. So whenever you upload an EPW file, it considers the X as the um, east and then Y as the north, most probably. Let me just confirm. We've got a sky dome, but I think it is too big. Yeah, it's too big. So here you can see the north. In the Y positive, the north is there, and X positive, the east is there. Let me scale it down by 1,000, so 0.001. Um, all right, let's increase it a bit. Just like make it 2 times larger. So this is the sky dome, and it is giving me information. Total radiation. Oh, for the entire year. Interesting. Okay, so this sky dome is giving me total radiation for the entire year, 1st Jan to 31st December. And the north is this way, the Y positive Y. Um, Let me hide it. Okay, so the north is towards that side where we can see these blue things happening even though there is no building. So I did not know that there is north here, but I was just assuming it to be here because it is so blue, and actually it is the same case. The sky dome is forming according to this coordinate system. Um, how do I? Yeah.
Also, a few time back you were saying about the
Mhm.
box, the area that it takes to analyze. Is
Yeah.
there a way we can reduce it or
Oh
increase it
yes,
as per the of the building?
very easily. Yeah, yeah, yeah. So if you are designing for a specific facade, for a specific face, and you are designing a facade for it, and you don't want to calculate anything else like the terrace and all, so you will have to. Um, I think you have to create a plane, or let me see if this works. So in Rhino, we can click on, press on Control and Shift, and then select a face. If I don't do that, then the entire box gets selected. But if I press Control and Shift, then I select a face. Let me just quickly check if I can select and put that in one geometry here. So I do set one geometry, Control Shift, and then click here. So it does not work. Okay. So you have to explode it or create a separate space. Let's explode it. And automatically this is not working now. Let's say I want to design for this face. I'm going to select that face, right click here, set one geometry, and only that face will now be um, simulated. Let me just hide it.
I'm not saying only that phase. Uh, Even it's taking one side and seeing the scale of the box. Like if it is taking a square of 1 meter, one
Yeah,
by one, then the map will show differently. But if it's take a bigger, if it will take a bigger scale
yeah, yeah, yeah.
of 10 meters, then it will show the map will show differently.
Are you
That
talking
really,
this grid size? Are you changing the grid size?
yeah, the grid size of the report.
What did you put it in? What do you put in grid size?
No, I did not try it. I
Oh,
was
okay.
asking
Oh,
whether you
sorry.
changed.
Oh, what will happen if I change it?
Yeah.
Okay, so okay, I'll just show you. So I'll put in 2, and then you can see that it is like more blurry kind of thing. If I put in 5, then it is taking 5 meter by 5 meter and then putting it into one um, simulation.
One color, yeah.
Yeah.
Also, I was trying with uh, this script is showing red. It's showing that the radiance has to be installed.
Okay, 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 okay. Yeah, I thought that might be an issue. Radiance, um,
It's another plugin that I have to install.
it's not a plugin, it is a software that is not like a normal software. Like, it is not like AutoCAD where you can see a shortcut file and it has some files. Radiance is something that gets into your system through the, that black screen thing, the command prompt thing. Like, let me show you. Like this thing we have. So we have to install it through here. It's very complicated. Even I forgot how I did that, but it took me a week to do all of this. Radiance installation. Let me just check how to get Radiance and ASM installed. Radiance installation Honeybee. Let me explain you how this everything is working. All of these things, the computational fluid dynamics, simulations, uh, these are not standalone softwares like SketchUp or AutoCAD. Like, you install a software and it will do everything. Um, so for a simulation to happen, you need some um, internal softwares that you cannot access, like Radiance, OpenFOAM. OpenFOAM is for that CFD, computational fluid dynamics. Okay, so that's inside. You cannot access it. If you want to access, you actually have to do command prompt and then learn coding and all of that. And that's what the engineers do. And that is why we haven't been we haven't been using it until lately. We architects and non-engineering background. Then came Grasshopper and all of the similar things, SimScale, Grasshopper. The Grasshopper is creating a portal for us to use this OpenFOAM and Radiance. So Ladybug and Honeybee itself isn't a standalone simulation tool. It is utilizing Radiance, OpenFOAM in case of Dragonfly, to make it happen. What I was assuming was that in the latest installation that we just did of Ladybug, I was assuming that the Radiance was also installed. So let's see how to install Radiance. Is this the error that is coming? Oh no, actually this is different. Um, so the Radiance files is in GitHub, definitely. Let me just check compatibility matrix.
It's actually saying no Radiance installation was found on this machine.
Understood. So we will install it. This is 2014. I think that won't work. This is 2022. Radiance installation for Ladybug, because this is important. I mean, others might also face the same problem. This is again 2014 question. Radiance installation not found. Oh, exactly your doubt. And this is in 2021. This is much closer. No Radiance installation found. They didn't find the solution. I've been resolved. Basically, uninstall Radiance and use compatibility matrix below. Okay, we have this compatibility matrix. Okay. So we have Ladybug tools of 1.8. And I cannot see 1.8 here. I think it is this one. So yeah, probably this is the Radiance that we need to install. Let me check. Yeah, I think that's it. I'll just copy, because as soon as I saw this webpage, I recall that I have been here before, installing these Open Studio and stuff. It is giving me PTSD. Let me just send you the link to this website. And so this is that Radiance 5.4 2023. You left click on it, and then you download it. Search for where to download it from. Should it be on the top only? Oh no, it's at the bottom. For windows.exe. Yeah, the fourth one. As soon as I click it, it has started to download, and now it will run as a normal setup. When you double click it, Radiance should be installed in your system, and then restart your Rhino. I hope you don't have to restart your system for Radiance. And it should work. It should work, Shreya.
Thank you so much. I'll just try it out and let you.
Sure, sure. Thank you for asking this. I thought like this will be really helpful for others who have uh, got into the same problem.
No problem.
Yeah. Um, Copy, paste, download this file for Windows. You will find this at the bottom of the page. There is for Linux and OS X also. Linux and all right.
So, again to interrupt,
Sorry,
it's
yeah.
asking whether to add it to system's path or not.
Sorry, it's
Yeah.
asking for.
Add Radiance to the system path for all users or current users. So do we add it to system
Oh,
path?
yeah, for all users. So basically, it's just saying that probably you have a guest account and a admin. So it is asking for all of the users. So yeah, just add it for all users.
Okay.
Yeah, that should work. I want to run it to see if it is, but let's just not do it. Otherwise, I won't be able to go forward. So yeah, I hope it works. If there is any errors or anything coming up, just take a screenshot and share. I'll be definitely able. I would love to like clear it out. Okay. So this is done. We were doing these days thing, right? Month, start day, end day. Okay, so let's do like 7 to 12. It's calculating. I don't know if it is changing or not. It is, I think, reduced. Last time the yellow was showing 9, 10. No, or is it the same? I do this, does it change? It's not changing. Summer, design, day, radiation. Oh, this is not connected to anything. Sky matrix. Okay. So this sky matrix is going in here and it is taking in the entire year. Oh, perfect. So what we need to do is put it here to make it work how I want it to work. Yes, now it's working. So it is looking at only the let me see, 21st of July, and it is like showing me these small numbers. Now I want 21st of July, 21st of August, 21st of September, October, November, December, 6 days, right? and now it is showing me the combination of all of this. Oh, it was a very rookie error that I did. Basically, I was just playing with some components whose output was not connected to our main script. Now I just shifted it to this. Now, what is HOY? HOY is hour of days. Now, the computer, we can tell the computer like 5th of January 2024, 6th of January 2024, and so on. But it is a bit more complex data for the computer to compute. Easiest way is to put the entire year as hours, like, and we'll talk in terms of hours. So, for example, 24 hours in a day, it's very easy to understand. But let's say we talk about a week in terms of hours. So, the Wednesday will become like midnight of Wednesday will become 48, right? And then 1 a.m. of Wednesday will become 47. Sorry, 49. And then 50 will be 2 a.m. of Wednesday. And if instead of saying 5th of July, let's take this example. Instead of saying 21st of July, we get the hour 4824. So right, 4824, and then 12 times I think it's gonna run. I mean for 12, so not 12, 24 hours it will run. 24. Let me check. I haven't ever checked this. So 24, 35, 47. Oh, where's 48? Okay, so 47. Till 47 it's running. 48, 49, 50. Oh. Okay, so there are multiple days that it is taken consecutively. So I think that's how it works. But you get it. So that is HOY. We are just converting what we humanly understand, the month, the day, the hour, converting it into computer friendly language, and then putting it into the sky matrix. The sky matrix is going into the radiation analysis. Oh, and even our sky matrix will change then. Where it, the sky dome, sorry. Look, all these values have reduced because we are considering only a few number of days. Okay. Oh, we even have the total area of the mesh that we are looking at. So I don't even need to do what I previously did. This area thing, because I think the total area and this will be exactly the same. This is 632. Oh, this is different. Why is it different? No, then this method is better. What I just did, like put area command and then get the area divided to get the per meter square kilowatt hour of solar radiation. Okay, any doubts? Sunidhi, Pratiksha, Ashwarya? Shraddha? Let me... I'm just adjusting these windows. It's so messy. Let's take like a 2-minute break before we go on to the next one, the daylight analysis, because now it will be very smooth sailing. Once you got this, it's almost repetitive. Okay. Cool. Um, I'll turn this off. Because I have never looked at this benefit matrix. It's pretty interesting. Residential buildings have balanced temperature. I have no idea what that is. Annual radiation benefit or harm. Interesting. And to explore what else it has, you can even look at its ladybug panel. It has all of these different things. This is a psychrometric chart, I think. Psychrometric chart.
I want to ask something on the same screen.
Yeah, yeah, yeah.
So, when we were exploring this annual radiation benefit,
Mm-hmm.
that is, we are taking it annually, and the start month and the start day that you were putting in, calculating for the entire year, or was it for a particular day?
So initially it was for the entire year. Um,
The one below, yeah.
this annual radiation was for the entire year, but now actually I've put in this analysis period. I've constricted it, and I've
It
asked.
still says start month and end month. So, like, if I have to put in only for like from sunrise to sunset for a single day,
Okay.
I can use the same table, or
Yes, yes, you can do that.
does it work only for the year?
No, no, no. You can do this like start month and end month is the same. Start day, end day is also the same, and you can put in the hours that you like to see. Let's say you want it from 6 to 15, that is 3 p.m. or even, oh, sorry.
If your start month and end month is same, it's for 1 month. It's not for the year, right?
Not for the year, yeah.
If I put 1 to 12, it's for the entire year.
Ha ha ha. Yeah. Oh, I exceeded 24, so it got red because end hour can only be till 24. Let me check. Yeah, so it is looking at only 12 hours. 4830, 3132, 33, till 42. Sorry, 13 hours. So on 21st of July from 6 a.m. to 6 p.m. Uh, there are 12. Oh, actually, there are 13 hours if we include that 6. So it is only calculating for these, and then we get the answer after turning this on for that time. And to check if this is actually true, let's put in some bad values like 1 a.m. to 4 a.m. So you can see that there is no sunrise and it is completely blue, so zero radiation. And now, like, a little bit of sun is coming in. Oh, sorry. Okay, and this is also changing. If we are starting from 10, then the sun is more vertical, azimuth is very high, and sorry, altitude. Yeah, and it is reaching more towards the ground area. So yeah, Shreya, we can go very specific and a specific day and look at hours, or we can go through months, or we can go through the entire year, whatever you like.
Oh, thank you.
Okay. And these are all clear direct normal radiation. This is not what's the other thing? Horizontal. I forgot the name. Um,
Global horizontal radiation.
ha ha ha. Ha. So it is taking it horizontal radiation, but oh yeah, so that's a diffused radiation, but we aren't using it anywhere. Probably we can use it and put it somewhere else. No, but this also has that diffuse. Oh, it's the same thing. The sky matrix is exactly the same. Ah, yeah. And the north should not be 20. Um, 20 means it is tilted by 20 degrees, so that's wrong. Should I forgot all of this. North for the counterclockwise. Oh, right, right. No, no, no. It's fine. It's fine. So it depends on how your building is there. So if you can rotate your entire model, then it's fine. But if you can't do that, then you can simply rotate the sky matrix to fit into your, let's say, Google Map image, and align it to the um, the north of that. So now it is, I think, perfectly aligned. Let me just check the sky dome and go to north. Sorry, top. Yeah, and let's just for checking sake put in 45. So the entire sky matrix is can be rotated according to your model, or your model can be rotated. I always rotate the model, but in case you want to do this, you can rotate the entire sky matrix. I'll just keep it 0. So when I send this file, again I'll send the Rhino file and the Grasshopper file. Open the Rhino file and then drag and drop the Grasshopper file to get all these geometries automatically, in it. Otherwise, you'll have to create geometries, right click, and then set geometries and all of that. Of course, for your project, you'll have to do that, but just to check how things are running, this will be much easier. And uh, I'm always confused with this Rhino millimeters and Grasshopper. What is it working on? So even if we do unit settings and go to meters, I think nothing changes. It asks to scale the model, but there is, oh yeah, there is a model. Okay, so click on no, and everything is fine. So yeah. Okay, let's quickly go, just like sift through the other example files, because I've explained you the how the process is working for a simulation. It's almost the same for other also, and you can now explore even by yourself. I'll open the there are so many things to share. uh, let's okay, let me open some other example file. Nice. So there is this research paper that I was looking at, and this is another sun path diagrams that can be generated through Grasshopper. This is the dry bulb temperature the entire year. This is the windrows diagram that can be created, and they've used the generative optimization using Grasshopper to um, optimize the massing of a building. Yeah, that was just something. And we look at samples, honeybee radiance. Um, let's do annual daylight. So in Mac, if you double click it, it's so convenient that automatically it opens in my already open Grasshopper. But when I double click it in Windows, a new Rhino file is opening and new Grasshopper file is opening, so it takes a while. I should have simply dragged and dropped it, but then that would have lost my earlier file. So just play with it as much as possible, and you will like get things like what's happening, how it works. Yeah. So the Grasshopper is opening. It will show not responding for a while because it's a heavy file. Okay. Let's see what it is showing in the Rhino. Oh, surprisingly, even the shaded is still like this. Even rendered, okay. Um, Let me turn on these B-reps. Opaque faces, context. Okay, so these are the context buildings. In the middle, we are designing our building. These are the opaque faces, the room solid. So these are the walls which will stop the sunlight. Sorry. And these are the openings, the apertures, the fenestrations of the building. All these green parts. See, apertures. Don't like don't look at all of the other nodes. Just understand what you need to change for this script to work in your in your model. So you would have to assign the context buildings and the solid walls and the openings where the light will come inside. Everything else is set. Um, so what are we looking at? We are looking at the daylight factor. We want to see how much light is getting inside the building. Let's just run this run toggle, double click and wait. Wow, it has opened up. Look, this is what I was talking about. So it is actually running the radiance in my, hidden in my PC. And it opened up this command prompt and it is now running the simulation. So this is what I meant by saying that the Grasshopper and all of this is just a portal to access the hard coding stuff that that we are not familiar with. So yeah. All right. True. But as you can see, it took like approximately 1 minute, and we are not able to see the results. Okay. I didn't want to see this. Wait a second. Ah, right. So there is a small error. The simulation that should be on that, it's coming so far up, probably because the workplace isn't set right. Work plane, sorry. Where would that be? Distance floor. The default is 0.8 meters, but this does not look like 0.8 meters. What if I change the units to meters and scale it? Okay, nothing happens. Um, 0.001. Let's see if that works. But again, it will take that long time to compute and everything. Yeah. Can I close it halfway? And to reduce the time, I'm going to increase the grid size to 2. That computation does not take that long. So yeah, you need a lot of patience to work with this sometimes. Oh, it is done, I think. Perfect. It is so satisfying to like fix the issue and it works. I had no idea this would work or not, but yeah, it did work. So of course this is not the ideal work plane. It should be, so I just need to figure out, is it 0.0008 or 0008? I mean, how many zeros are gonna be there so that I get that 0.8 meter height perfectly. But just for now, this is how it is working, and it is giving us like a lot of light here because there are so many openings, and this building is not blocking. Let's check the dome if we have it here. No, we don't have the sky matrix. But yeah, you can put in that sky matrix the from this one, visual sky matrix. Put it there and see where that sun is. What is the sun path? And make your um, assumptions and conclusions. So yeah, this is definitely north on the top side, I think. Look, they are also using the EPW file. This goes into here. The north is unchanged, so default north is at 0, so that's north on the upper side. And you just have to ignore all of the other things basically, and it gives us the required outcome. What we as architects are gonna do, we're gonna change the height of the building, maybe um, introduce trees or remove trees. We can change the size of these windows and see what happens. So let me quickly try that. Aperture. So it is taking into consideration all of these openings, right? What if I can show no objects are hidden? Do I have to bake it? The problem is that these geometries are inside it. So if I bake it, then I'm gonna get these surfaces. That's nice. And let's say I remove a lot of surfaces just to check if it is working or not, right? Um, let's select all of these and this one, and then right click and set multiple B-reps. Now it's gonna run the script again. So what I've done is I've removed that small ventilator on the left and I've removed the skylight on the top. Let's see what happens. Right now the percentage here is around 83%, 70 to 80%. So it should ideally reduce a lot because I'm removing the skylight. Oh yeah, perfect. So it's like a completely dark room now. And this window is there, so it is working. every single time like the script runs, I am also always like always on the edge, like, oh, will it work, will it show an error every time? But yeah, it works, and then it gives you that satisfaction. So yeah, I hope you get how to manipulate the script without even understanding the script. I also don't know how it works. I don't know what's the maths behind it. um, but that's the thing about it. Like, we as architect, we've got an expertise in spatial designing and recognition, and we need to focus on that. This is just a small tool that is giving us a feedback in a very empirical and objective manner. So let's focus on designing rather than this mathematics and stuff. Cool. So any doubts? Mm, so yeah, I guess that's good. I've equipped you with the um, method of understanding a script, manipulating it for your context. Um, you know how to install plugin, um, how to manipulate certain geometries, and even if you don't know how to manipulate geometries, you can simply get it from SketchUp, put it here, and then plug it into this simulation and make it run. And as you can see, the daylight simulation is very similar to the solar radiation analysis. Similarly, other things will be very similar to each other. Um, yeah. And so the main aim was to give you that foundation, that base, which allows you to explore further even by yourself. Or when you're looking at tutorials, you get it within a few minutes rather than trying to figure it out for hours. Um, so yeah, trying to understand what's unnecessary, you just ignore it. Like in this script, we ignored the parts that were not relevant to us. So yeah, that's good for today, I think. Tomorrow we are going to apply all of this and a lot more. I'm going to give you glimpses of a huge number of things that we can do on Grasshopper, um, and how to optimize buildings. Like right now, I removed that windows. I was like, it is in my hand to increase or decrease the shape of the building, or size of the building and stuff like that. In the next class, we are going to look at generative optimization, where the computer is going to change the shape of the building for you. You just have to tell it what you need at the end. Like, I want minimum solar radiation for that building, so it's gonna create and put it in such position, in such a shape that it gets most shade, or I don't know what it will do. It's that's crazy. Like, it's kind of artificial intelligence, but not really. Um, so yeah, that's pretty like cool to see computer automatically creating iterations, like 10,000 iterations, and then selecting 100 best through machine learning. And then we as an architect, remove certain, like, no, these shapes are uninhabitable, and then we select a few of them. It's pretty crazy the stuff it can do. Yeah, cool then. Any last round of doubts or questions or comments or anything? Ashwarya, Shraddha, Pratiksha, Shreya.
If we try this out and do like multiple iterations,
Yeah.
can you also show us how to like make a video of it, like with the iterations changing, so that we
Ah,
can
yeah.
present it well, like
Correct,
multiple
correct.
iterations it can be shown in a form of a video. Yeah.
Correct. So, when the multiple iterations happen in that in the script that we are going to look in the next one, so we can do a screen recording of it, um, and you can see that it is like changing the iteration, like a different building, different heights, and everything is happening. But what's even better is, let me see if I'll show it on that day itself, because I think I'll have to search where it is. It
Okay.
records all of these iterations, and I can spread it out uh, within a few seconds when we make those uh, components in such a manner. And then you can create animations, or you can just have these static images with all of these iterations laid out, and then you can highlight a few of them which the computer has selected or which you think is better. If you want to animate it, then uh, then I think you can like put all of them together in one spot. There is a, of course we can have that grasshopper script to hide everything else and only show the first one, and we can take a screenshot, then the second one, take a screenshot. If you don't want to take a screenshot, there is an inbuilt um, what do you say, feature in grasshopper where we can right click on a slider and click on animate. Let me show you. It says 7. Yeah, animate. Okay, so what it's gonna do is it's gonna run from um let me see. Yeah, it's gonna run from, oh right, it runs from 0 to 10, like whatever the minimum and maximum value of that slider is. It's gonna keep it on 0, take a screenshot, keep it on 1, take a screenshot. And we can uh, put it like how many frames we want. Like in this case there are only 23 frames. We can have like 100 frames, and instead of 0 to 10 I can have 0 to 1000. So it's gonna take so many screenshots, and then we can create a GIF out of it, and it will be a video that will be like, either the objects are moving or the objects are like changing really fast and all of that. So
Yeah.
yeah, and then there is a,
This one will just save the PNGs, right?
yeah, it will save PNGs into a folder, and then on website there is GIF maker, which will select that folder and create a video out of all of those pictures, and it will be like a smooth video. You remember the video I showed you? It was created through this animate. Let me show you. Like all of the video, most of the videos I think I've created were through this. But that's like a completely different and elaborate thing I can talk about. So let's say, yeah, this one.
But like I have to keep the model at the same place and just change the script. I have to
Um,
copy it at the same angle, same place.
yeah, I'll just show you. So here you can see this preview thing. Right now the camera is set like this. Like this will be
Okay.
the like this will be the image I mean this is the position that it's gonna take the image from as it is moving the slider. So in my case, uh, this is the position, and my slider is like changing the path of the sun by like point 0.1 meter, point 0.1 meter, point 0.1 meter. And with that, the same slider is also changing, you see the rotation of my panels. So all of these panels and the sun is connected to the same slider. So yeah, so you get this.
So it's not a different model, it's just one script.
Ha ha
It's
ha.
scripting multiple frames for the range you have given.
Correct. Definitely, exactly. So
Okay.
that's how it is.
Also, in next class, can you please cover like if you can use models from the other software? So like if I
Oh
want to
yeah,
import
right,
and
right, right.
I use the same script for my existing model.
Yes. We should do that. So we will do that for SketchUp. Like we can make a model in SketchUp and then import it here. That's like barely 5 minutes. So I'll cover that the first thing in the next class.
We cannot do the same from Revit.
Oh yeah, Revit also we can do that. I think I've never done it, but yeah, I can show that. The problem with Revit, I think, is um, I'll just check and see, because probably there are too many surfaces in Revit, and all these simulations and everything, as you can see, works good on block models without any complex geometries like plane figures. So even when I had to run simulation in my case, and in the last class I did it for some other person, one another student. So I took her SketchUp model and simplified it, and then imported it into Rhino, simplified it further, and then I put it into Grasshopper. So it needs like very clean, simple block models to work with.
Okay.
Yeah, so that's why I think I haven't tried with Rhino, but I'll see. Like we'll see if it works. And this animation was this snapshot feature in Rhino, where you can like create a snapshot, move something, then create the second snapshot. Oh, just like SketchUp scenes, right? You go from scene one to scene two, it creates an animation. But that's just, I think, video animation. I don't know if it moves the objects also. But in Rhino, it is like in scene one, the object is here and the other object is here. Scene two, the other object is here. Sorry, snapshot two, the other object here. Then it will create this animation. So all I did was just move things and just like
So you
zoom
don't
in.
know the command to move the things here, like how the fins are rotating and how these things are.
Sorry, I didn't get you.
I'm saying we still don't know how, the commands
Ah,
with the things, like how the fins are rotating. We still don't know the script for that and
in
this thing.
okay. So in that twisting tower, I covered the moving part. If you remember the Z thing, all of this is not like this part did not touch Grasshopper. All of this animation and everything, nothing touched Grasshopper. It is purely Rhino based animation. This was a bit complicated. Where it is? Yeah, this one. This is purely Grasshopper animation. Uh, so yeah.
No, but
Mm,
in the script we were giving only one angle. No? So how is this rotating at different angles?
um,
That again, like you just took the snapshot and it's a PNG or it's like some command for motion.
no. So the thing is, the sun is not rotating. Uh, you see that curve? So I manually made that curve, and then I divided it into 1,000 points, and then I'm telling the sun to move 1 point at a time. So it's very like manual way to do it. The panels on that building are rotating around their axis. Uh, so yeah, that's the makeshift thing I did.
Okay.
Yeah.
But yeah, the panels that are rotating,
Uh-huh.
they, the script that we have, we can only give one angle. Range to
Ah,
from one range to the other, that is what I'm asking you.
okay. Yeah,
Just
we'll
to
have
show
to.
we don't know how that works.
Yeah. Yeah, it's a bit deep dive into this specific project, because um, like there are several ways you can do it. Uh, s- yeah, I mean it would be a very long conversation if we talked about it. So yeah, but you will get it eventually. Of course, like we can't learn everything in just a few days. It took like 1.5 years to reach that stage, and then half years to make the stuff that I'm doing. So
Sure.
yeah. But
Thank
yeah,
you.
glad you asked about it. So all this animation, there is a Horster plugin that you can use. That's a completely different set of things. Like I can take a 5 hour session on that, how to create different types of animations and connect different things, logic behind animations, and a bit of maths involved. Um, so yeah, that would, but that is possible. Like you can create any type of animation you like. Um, yeah,
Okay. Thank you.
most welcome, Shreya. Okay then, let's end our class for now, and hope to see you all in the next session. Thank you so much for your patience, and hope you have a good night. Bye.
Thank you. Good night.
Hey, Shreya.